Joey Chestnut is an American competitive eater. On average, he can eat 7 hot dogs per minute. This situation can be represented with the equation y equals 7x, where x represents the number of minutes and y represents the total number of hot dogs eaten. Create a table of values for this scenario and graph the result. I'm going to ask that you pause the video now, go ahead and create a table of values and graph the table of values that represent. Okay, so please check your table of values, make sure they match the table of values that you see here, and that your line also is here. Now we haven't answered this question. It says, is this data continuous or discrete, and how do you know? Well, if I think about the situation, the number of minutes is always continuing. Okay, we can't stop time, and you're not going to just eat 1 hot dog and then 2 hot dogs. You're eating the whole hot dog, every piece of it. So this would represent a continuous relationship. Oops, I just messed all that up. Let me put that back in the right place. Let's see, 1 and 7. I think that's about right. Okay, so a continuous relationship. And connect all those points. Okay, so we have our table of values and we have our graph. Let's look at our graph a little bit more in detail. So we're going to look at specific points, some points that should be seen on our graph and some points that are not. And we're going to prove algebraically, sorry about that, if they fit our relationship. Okay, so for example, 9 and 63. Does this fit this relationship? On my graph, I don't see 9 and 63. So what else do I know? Well, I know y equals 7x. So if y equals 7 times x, that means 63 should equal 7 times 9. And this should be a true statement if this fits the relationship. 7 times 9 is 63. So this is a true relationship, so yes, it does fit the relationship. Okay, does the ordered pair 4.5 and 40 also fit this relationship? Well, that I can see on my graph. So let's come over, let's find 4.5 and 40. Well, no, it doesn't fit the relationship because it doesn't fall on the line of y equals 7x. No, it lies above the line. Does the ordered pair 8, 30 also fit this relationship? Explain. Well, 8 and 30, let's find 8 and 30. Well, no, it falls below the line. Okay, so only when it falls on the line for this does it fit this relationship. Okay, so we're going to switch things up a little bit. So Joey wants to win the competition, but the total number of hot dogs he must eat must be more than 7 hot dogs per minute. So he has to be better than his average. The inequality we can use to represent this is y is greater than 7x. X represents the number of minutes, and y represents the total number of hot dogs eaten. Okay, so we have y is greater than 7x. What are some possible ordered pairs that would fit this relationship? Okay, so if I want things to be greater than 7x, let's kind of think about our relationship. Now, before, when I had y equals 7x, we knew that he could eat 7 hot dogs in 1 minute. Well, he needs to eat more than 7 hot dogs in 1 minute. So let's just pick a value. Let's say, well, 10 is more than 7, so let's say he can eat 10 hot dogs in a minute. Okay, what about 2 minutes? Well, he needs to eat more than 14 because that's what he was eating before. So let's say he needs to eat 15. And 3 minutes, he was eating 21. So let's say he needs to eat 25. And 4 minutes, he had eaten 28. So let's just say he needs to eat, I don't know, 35. And in 5 minutes, he was eating 35. So now let's say he needs to eat 45. Let's think of some other ordered pairs. Let's continue. Well, in 6 minutes, remember he was eating 42 hot dogs. So let's say he needs to eat 50. And in 7 minutes, he was eating 49 hot dogs. Let's say he needs to eat 60. Okay, so let's go ahead and look at our relationship here. So what we're going to actually plot the ordered pairs that we came up with. So we have our linear relationship, but I want to know what values he needs in order to break his record, to eat more than 7 hot dogs per minute. Okay, so for instance, in 1 minute, he'd be eating, we said 10. And 2, he could eat 15. And 3, he could eat 25, we said. Okay, I'm going to go ahead and let you pause the video and fill in the rest of the coordinates that we put on our table. Okay, these are all the values that I could fit on the graph. So if you'll check those values. Okay, and what do you notice? Well, something that you should notice is that all the points are above the line. So does the ordered pair 749 fit this relationship? This relationship of it needs to be y is greater than 7x? Well, all of these values are greater than, but is 7 and 49 greater than this relationship? You should say no. That's what he ate originally. So it's not greater than, it's equal to. What about 4.5 and 40? Let's think about it. Okay, so 4.5, let's come up to 40. I'm going to plot that point here. Well, that appears to be above the line as well, so it seems to fit that same pattern. So it seems to be that it would be greater than what he would normally eat in 4.5 seconds. So yes, because it's above the line. What about 8:30? Let's come to 8 and 30. Now, think about how much he ate before at 8 minutes. Before, he was eating 7 times 8. So 7 times 8 is 56. So he was eating 56 hot dogs before. Well, you should be able to clearly see, obviously, that 30 hot dogs is less than 56 hot dogs. But also, you could see that this is not fitting the other pattern that we came up with. This point is below the line. So no, it doesn't fit the relationship because it is below the line. Okay, so all the possible ordered pairs of y is greater than 7x were above the graph of y equals 7x. Any ordered pair in the shaded region above the graph of y equals 7x would make the inequality y is greater than 7x true. Take the point 1 and 10, for example. It lies in the shaded region above the graph of y equals 7x. If Joey could eat a total of 10 hot dogs in 1 minute, he would be eating more than 7 hot dogs per 1 minute. So this point right here proves that the inequality to be true, that 7 or that y is greater than 7x, that 10 is greater than 7 times 1. Notice that our solid line changed to a dashed line because we discussed that nothing on the line would be greater than what he did before. Everything would have to be above the line for it to be greater. So my line is not going to be solid any longer. It's going to be dotted. Okay, and this is just for us to see mathematically why 10 satisfies. So if I plug 10 and 1 in, so my x and my y value, 10 is greater than 7. So the ordered pair 1 and 10 proves the inequality statement true. Please remember to pause the video to catch up on your note sheet at any point. Okay, so all the possible ordered pairs of y is greater than 7x were above the graph of 7x. So this point here that you see, oops, will not satisfy my solution. Any ordered pair on the graph of y equals 7x would not make the inequality true. Take the point 535, for example. It lies on the graph. So my point right here. If Joey could eat a total of 35 hot dogs in 5 minutes, he would be eating the same as 7 hot dogs per minute. So let's look mathematically. Y is greater than 7x. 35 is greater than 7 times 5 is what we are testing. So I plugged in my x value and my y value. When I test this out, I get 35 is greater than 35. No, that's not true. The ordered pair 535 proves the inequality statement is false. Also notice that all the possible ordered pairs of y is greater than 7x, we said it is above the graph. So any point below the graph of y equals 7x would not make the inequality y is greater than 7x true. Take the point 315, for example. So now we're looking at this point. It lies below the graph of y equals 7x. If Joey could eat a total of 15 hot dogs in 3 minutes, he would be eating less than 7 hot dogs per minute. So y is greater than 7x is our inequality that we need to hold true. So we'll plug in our x value of 3 minutes, and our y value of 15 hot dogs. And if we test that out, we get 15 is greater than 21. No, that is a false statement. So that means the ordered pair 3 and 15 proves the inequality statement false. In order for Joey to lose his next competition, the total number of hot dogs he eats must be less than or equal to 7 hot dogs per minute. The inequality y is less than or equal to 7x can be used to represent the situation where x represents the number of minutes and y represents the total number of hot dogs eaten. Okay, so now we don't have y is greater than 7x, but we have y is less than or equal to 7x. What are some possible ordered pairs that would fit this relationship? And also notice that we have less than or equal to. Okay, so if it can be less than or equal to, I want you to pause the video for a minute and see if you can fill in your table of values. And come back and see if your table of values follow the same pattern as my table of values. Okay, so if you will check your table of values, they don't need to be identical to mine. But notice that all of my values are less than or equal to the original values of y equals 7x. Okay, so I don't have 7, but I have 4. But if you notice down here, for, let's see, for number 4, for 4 minutes, I have 28. So that one's equal to. Okay. Okay, so if you'll take a minute and graph those points just like we did before. So pause the video and graph those points. So what do you notice? You should notice that this time all the points are on or below the line. Okay, I'm going to switch colors. Does the ordered pair 749 also fit this relationship? Well, let's look. 7 and 49. 7 and 49 is one actually that we had, and it's on the line. And we said that all the points are on or below the line. Yes, because it is on the line. Does the ordered pair 4.5 and 40 also fit this relationship? 4.5 and 40. No. 4.5 and 40 is above the line. Does the ordered pair 8 and 30? Well, 8 and 30. Sure, 8 and 30 is right here. So yes, because it is below the line. Okay, so notice that we have a new inequality here. Okay, notice that it's shaded now below the line to represent what we just explored. Notice that I also have a solid line. So any ordered pair in the shaded region below the graph of y equals 7x would make the inequality y is less than or equal to 7x true. Take the point 625, for example. It lies in the shaded region below the graph of y equals 7x. If Joey eats 25 hot dogs in 6 minutes, that is less than or equal to eating 7 hot dogs in 1 minute. So let's look. Y is less than or equal to 7x, and if we take our value of 6 minutes and 25 hot dogs and plug that into our inequality, I get 25 is less than or equal to 42. Well, that's true. So this proves the ordered pair 625 proves the inequality statement true. So this point would satisfy this inequality. Okay, let's look at 5 and 35. Any ordered pair on the graph of y equals 7x would make the inequality y is less than or equal to 7x true. Take the point 535, for example. It lies on the graph of y equals 7x. If Joey could eat a total of 35 hot dogs in 5 minutes, he would be eating an amount equal to 7 hot dogs per minute. So let's look at our inequality. Y is less than or equal to 7x. I'm going to plug in my 5 minutes, my 35 hot dogs, and I get 35 is less than or equal to 35. That's a true statement because 35 is equal to 35. So this proves that the ordered pair 5, 35 proves the inequality statement true. Let's look at a point above the line. Any ordered pair in the region above the graph of y equals 7x would not make the inequality y is less than or equal to 7x true. Take the point 330, for example. It lies above the graph of y equals 7x. If Joey could eat a total of 30 hot dogs in 3 minutes, he would be eating more than 7 hot dogs per minute. So let's look mathematically. Y is less than or equal to 7x. So let's plug in our value of 3 minutes and 30 hot dogs. 30 is less than or equal to 21. That is not a true statement. 30 is not less than or equal to 21. So the ordered pair 330 proves the inequality statement false, meaning I'm not going to shade in that region. I'm going to shade in the other region that is present on the graph. Okay, so here are the steps that we're going to follow when we are graphing. Let's look at one where we are graphing without a situation. We're going to start by determining the boundary line. Make sure it is in slope-intercept form. In this case, y equals 2x plus 3 is the boundary line. So I'm going to come and I'm going to graph my y-intercept and then my slope, so up to over 1. Okay. And then I will graph my line, but my second step before I graph my line is to determine if the boundary line is dashed or solid. Since the inequality sign is greater than or equal to, the line will be solid because points on the line are included in the solution. So we are going to have a solid line. Third, we're going to graph the solid boundary line. So I've just done that, and if you need to pause the video to catch up, please do that for yourself as well. Determine which side of the boundary line to shade by testing an ordered pair on each side of the boundary line. Okay, so we haven't discussed this except on your foldable last night, but I'm going to take my origin because it is the easiest test point. So 0, 0 is below the boundary line. So I'm going to plug that in. 2 times 0 plus 3, and I've got 0 as my output as well. 0 is greater than or equal to 0 plus 3. 0 is greater than or equal to 3. No, this is not true. So this point that we placed on our graph, sorry, my point got a little messed up. Let's fix that. Okay, does not satisfy the solution. Since it does not satisfy the solution, we are going to shade in the opposite region. Okay, I want you to try the next one on your own, but notice this one you're going to have to convert, solve for y, okay? And we will check these tomorrow when you come into class.